Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1, Forces, and we're doing 1.2, the virtual experiment, and weight and the spring scale. So please find your book and follow along. Have you ever seen a photograph of someone standing next to a big fish that he or she caught? Chances are the fish was hanging from a device that showed its weight. Weight is the pull of the earth on an object, and the device that measures it is called a spring scale. In this experiment, you will use weight to calibrate marks on the spring scale, such as the one shown in Figure 1.1. So this is Figure 1.1, and this is the spring scale we will be using together online. So for the purpose of this experiment, your unit of force will be the weight of a volume of water specified by me. An empty plastic milk bottle makes a good container for the water. To make a measurement scale that can easily be removed, attach a strip of masking tape over the two sets of permanent marks on the spring scale. Then hang an empty plastic milk bottle from the spring scale and carefully mark the position of the force indicator on the masking tape. Since there is no water in the bottle, write 0 next to the mark. Figure 1.2. Do you see where there's the masking tape and a mark? Use a 250 milliliter beaker to measure out the amount of water specified for your team. Pour this water into the plastic bottle and again mark the position of the force indicator on the tape. Write 1 next to the mark. Now measure out the same amount of water that you used the first time and add it to the water already in the milk bottle. Mark the position of the indicator and label it 2. Repeat this experiment until you have labeled all the way up to 5. The marks you have just made form a measurement scale for your spring scale. The distance between marks is called the measurement unit for your scale. In your case, the measurement unit is the weight of the amount of water you added in each step. So some questions are, what are the distances between consecutive marks on your tape? Does the spring scale stretch by equal distances for equal increases in weight? Next, make a smaller or lighter mark halfway between each of the marks you labeled on the tape. What is the value of this division? So I will provide you with an object. Measure and record its weight, reading the scale to the nearest half unit. Compare the weight you measured for this object with the weight recorded by other students in the class. Do all the groups report the same weight? In order for everyone to be able to compare the results of different weight measurements, we need a standard unit for weight. The standard for weight and for all forces in the metric system is the Newton. If you look at your spring scale, you will see that one set of calibration marks is labeled N. This is the abbreviation for newtons. A newton is about the weight of a small apple or a quarter-pound burger. To get a better feel for the newton, try pulling on the spring scale with a force of 1 newton. Then try to estimate the weight of a few objects given to you by your teacher. Weigh these objects and record their weights in newtons. Carefully peel the masking tape from the spring scale and attach it to a page in your notebook. You will need this tape for a graph you will construct in the next section. Now that we have read the experiment, we're going to do a pre-lab, mostly just like we have done before. So you're going to come up with a purpose of the lab. And so what you'll do is you'll double click in this box. And I am getting a little bit ahead of myself. There is an assignment on Classroom with this Google Doc in there for you. And then once you open that up, which you should do now, then you're going to double click on the box and this will pop up. And then if you click inside, you should get your cursor and then you can fill it in. The purpose is to, and you'll want to finish the sentence with what you think the purpose of the lab is and make sure to put a period. Then make sure to click Save and Close. And then, just like we would do normally in school, you will click on the next box and you're going to summarize the steps of the experiment in 5 steps. And I encourage you to summarize the steps as if you were in the classroom. So no need to adapt it for being online yet. Just what do you think you would do if you were in the classroom, and write those 5 steps out, and then save and close. And then our prediction. So there are several things that you could predict. Perhaps you could predict if you think if different people are given different amounts of water, like 50, 100, or 150, or 200 milliliters, will their special weight unit be standard, or will it be different from everyone else? And so then if I give you an object, will everybody's object weigh the same given their different standard weight unit, or will their objects have different weights given their different special weight unit? So one prediction you could make is that everyone will have the same scale if they're given different amounts of water as their weight unit, or everyone will have different scales if they're given different amounts of water for their weight unit. And then want to save and close. And then when you are done with your pre-lab, you'll want to turn it into Classroom. And in our next video, we're going to do our first virtual lab. All right, see you then. Bye.